I sit right here. Oh,
okay, you guys sit in the same proximity where you were sitting before. The only changes would be this section right here. Ian, grab the second seat right there. Okay? That should work the same for you.
it's on. You got no
Okay, we're starting a new chapter today, so Chris is going to pass out your chapter assignments. Go ahead and put that away. Let's see, we're missing Brittany's here. Okay, everyone's here. Okay, attendance is on. What? Okay. Okay, get your assignment. Go ahead and put it away for now. I don't know if you want their assignment sheet, but this is what we're going to work on in class for a little bit today. Okay. Yes. Go ahead and keep it for later. Yes. Well, we'll worry about that later.
I don't know.
Okay?
Just you and your mom.
Yes, Austin.
Do you want us to put our folders up or are we going to put it in?
I just want you to put your assignment in your folder and put your folder away. I will give you a sheet that we're going to work on today that you can take notes on. Okay, the only thing you need on your desk is this piece of paper I'm going to give you and a pencil. You don't need your calculator right now, no. You don't need your book right now either. Send that 5 to that other group back there.
I'm a bad girl.
Yes, Tim. Please excuse tardy. Okay. Where did I sit?
Right there.
Okay, I have you broken into groups today because I want you working. We're going to work on this individually and we're going to work on this as a group. I do not want you to begin anything on the assignment, so turn the paper over, please. You didn't get one? He has one?
Yeah.
Okay, so turn it over. And most of chapter 8 that we're going to deal with is dealing with exponents. And for exponents, we have to remember back from, we're probably first introduced to you in 5th grade. You learned about 2 squared and 2 cubed. Okay? Remember on the composition of your exponent, it always has a base number, and then the power or the exponent is a number that it has risen to. Okay? The exponent stands for the number of times that the base is going to be multiplied. So if we have 2 cubed, it tells me that the base is going to be multiplied 3 times. 2 times 2 times 2. And the thing we're going to learn about in this unit is exponential growth. If we look over here, we have 2 cubes. This would be like 2 to the first power. So if we made it 2 squared, which would be 2 times 2, we would see that it grows to 2 squared. That's 2 times 2, right? 2 cubed is 2 times 2 times 2. 2 to the third power. You see it's starting to double in size. Then if we go 2 to the fourth, you're looking at, and you see how quickly it starts to grow? Okay? Now 2 to the 4th is how much?
16.
16. See if I can get this to stand here. I don't know if I will. Okay, so 2 to the 5th would be how much?
25.
32.
Well, we know that
32.
2 to the 4th is 16. And we take that and multiply it by 2 and we get 32. Okay? So you see it is continually doubling. Look at the growth. It's very, very big. Okay, so whenever we're dealing with powers, kamikaze, whenever we're dealing with powers, we're going to see that the growth goes quickly. Okay, so think about that in terms of a graph. We've looked at slope, right? And we've always had a constant slope. What do you think if we were going to graph 2 to the x power? Think about that in terms. We found that 2 to the 1 was 2. 2 to the 2 was 4. 2 to the 3 was
6.
and 2 to the 4th was
16.
What do you think that graph's going to look like?
A curve.
Yeah, it's going to be a curve. Think about that. 2 to the first power, we get just 2, right? Then we go up to 4. We go up to 8. We go up to 16. We get some significant growth. Okay? Yes?
Would it become a parabola if you go to the negative side?
That's a good question. We're going to explore that in this unit, okay? We're going to start dealing with the negative exponents. But first we're just going to play around, and there's certain rules that you have to learn when you deal with exponents, okay? And that's what you're going to work on as a group and individually. And first of all, there's going to be 3 different rules that we're going to find out about when we multiply exponents. And what I want you to do on your worksheet in front of you, we're going to work on just section 1 right now. But before we get there, I'm going to go through the 3 different rules of multiplying exponents, okay? If we think about this, what does 2 squared mean? That's 2 times 2, right? And what does 2 cubed mean?
2 times 2 times 2.
Okay? Now, if I want you to write this out as a solution, we could go 2 times 2 is 4 times 2. But I want you to write it out as a solution of a power. What would this equal?
2 to the
5th power. Okay? Then let's look at this. What is this telling me now that I have parentheses? Well,
you have to do it
2 to the 3rd power times 2 to the 3rd power, right? We have, because it's squared, we're taking the inside and we're multiplying it twice, right? Yes, Lucia.
Is that the same thing as doing 2 to the 3rd power and then just like getting the answer?
Well, right now I'm not in terms of finding out what the actual value is. I'm trying to find out what the power would be, okay? So I'm saying here I have 2 to the 3rd power and it's squared. So I have to take 2 to the 3rd power and multiply it by itself twice, right? Well, we can even break this down further. What is this? 2 times 2, and this is 2 times 2 times 2. And what do we get here if I write it as a final power? 2 to the 6th power. 2 to the 6th power. Okay? Now, for the last example, what's being squared here? 2 and x, or just
2.
both of them? This is 2 times x times 2 times x. Or because we have the associative property in math, we go 2 times 2 and x times x, right? Is that any different?
No.
Okay. And this is 2 squared times x squared, right? Okay. Turn your paper over. Look at section 1. For the next minute, I want you to do the first 3 problems, and in your head, think if you can come up with a rule after you've done these problems for multiplying these exponents. See if you see a pattern developing on your own. Don't talk to your neighbor, just do those 3 problems. And if you need to expand it out to get the answer like I did, that's what I'd like you to do. Expand the problem out, the multiplication out, and then combine it with an answer to a power. Okay? Okay, expand that out. Expand it out on your paper. Okay, expand that out. Show me what that is. I want you to expand those out, all of those out, before you come up with your answer. Okay? Expand those out like I did on the board, please.
Right.
Yes, I want you expanding them out. Good. And then give us the final answer.
So you want us to just branch off and just...
Yep.
Okay.
Yes, Brett.
Just asking if I'm doing it right. Is that right?
Yes. Okay. Okay, now that most of you have the problems worked out, I want you in your group to discuss if you see something, a pattern developing when you're multiplying the exponents. If you see something that you can do with the exponents. Discuss it with your groups.
Do you want us to do our whole thing too?
Yes.
I already know.
Yeah. Don't you like add the little exponents together to get
No, you all aren't.
Well, yeah, that too, but when did I come for the rule?
Did you come up with a rule?
I understand.
Okay, so then what that doesn't show me a rule though. What is a to the m times a to the n? If you say you're going to add exponents, how would you write that? Okay, what's your base? Remember, your exponent has to be written to a base. What's your base in this problem? Okay. And so you're saying then that you just add the exponents. Okay, very good.
See, add the exponents. Add the exponents to find your...
Okay, so you're just saying that you're going to, yeah.
To find your base exponent? Or how would you say add the exponents?
Add the exponents is sufficient.
Add the exponents. That's how we have to put. So you have to add the exponents.
So then show me that.
Now I just know how to spell it, right?
Robert, what did you find out?
What?
When-
I was going to ask you a question.
Okay, ask the question.
Do we have to write it in words?
No, you can do it in symbols, Robert.
Okay, in that case, we
If I have a to the m times a to the n, what did we find out when we multiplied?
a to the m plus n.
Okay? Did anybody get something different? Okay, what'd you get, Chad?
A to the m in parentheses and then n on the outside of the parentheses.
A to the m in parentheses into the outside n. Okay. So then you found, so how would I do it if I had a to the 2 to the 4?
You would 8 is 6.
Okay, so you're saying that if you have it this way, it's being added. Okay, what does parentheses stand for in math? Okay, so would someone seeing this say, oh, multiplication or addition, do you think? Multiplication. Okay, so then how are you going to show me, since you tell me that if I add these two, that's going to be the answer, how can I show it such that it's being added?
What Robert says.
Okay. Okay. So yes, Austin.
I got A and then 27
On which problem?
on the rule.
Okay. And what did you plug in for M and N then?
Because I said N, because A to N through the ABCs is 13.
Okay, so you took all the You took all the A's out of the problem, right? Okay. Those were just examples that you were looking at to find a pattern. Because if you look at the first problem, we had a squared times a to the fourth, and we got a to the 6. And 2 plus 4 is? Okay. Then we had a squared times a. And what's the exponent on a?
1.
So 2 plus 1 is? And we got a cubed, right? For number 2? And then on number 3, we had a cubed times a to the fourth. So 3 plus 1 plus 4 is?
8.
A to the 8th. Okay, so you found that when we are multiplying the same base, did you notice that the base had to be the same? Okay, when you multiply the same base with exponents, we just add the exponents to get the new answer, right? Okay, let's look at section 2. Do problems 4 through 6, multiply that out, and see if you can find the rule for that. And I want you to expand it. It's very important that you expand it, because if you expand it, you'll be able to see the pattern much more quickly. Yes. Okay. Okay, that's cubed, right? So how many times would you multiply the inside part? What's in the inside part?
The 2 squared.
Okay, so write a squared. And how many times would you have a squared?
3 times.
Okay, so write that out.
Break it down.
Okay, so now you have that. Can you break that down even further now?
I did.
What's a squared look like?
A times A.
Okay, and then you have to have how many sets of those?
3.
3. So then you write that out, you've expanded it.
Be A by A by A by A by A.
So how many A's would you have?
6.
A to the 6 power. Good. Okay, so make sure you expand it out. Yes, Lucia, did you have a question?
No, I was asking the same thing as she did, but I heard you.
What's that?
How you just write it 3 times, write this 3 times?
What's in the parentheses is being cubed, so it's 3 times, right?
Yeah,
Okay,
so
then how do you break out your a squared?
2 A's?
You go 2 a's, right? A times a, and you do that 3 times, right? So how many a's do you end up with?
6.
A to the 6.
So then it'll be A to the 6. Who got A
I
to
drove
the
with
5th?
6 A's. I
Okay,
got 5 A's.
did you do?
times 3 is 6.
Okay,
And that's
show him.
So see, you do.
Well, no, show him, Lucia. Show him how yours is broken out. Explain to Chad how that works.
There's 3, it's A squared times 3, so you have to do 3A squared, and then you have to break it down to A times A, because that's what A squared is, and then you do that for each of them, and that's 3
So you're going to multiply your
A
exponents, right?
squared, which is...
Okay.
So you can multiply
Did you guys
the
have
2
it?
and 3 and that's it.
You have your rule?
That's what I did.
What's your rule? Don't forget your rule. Don't forget to do your rule if you have determined it with your group. Yes.
Can we show that it was multiplying?
Okay,
Show it any way we
that's
want.
exactly, yes.
Hi, I'm on TV.
Yes, Duna.
So number 5
Okay, so you have a squared, right? And how many times do you need a squared? 3 times. So you have it once here. Where's the other 2 times? Don't you need 3a squareds? No, no, no. Don't look at that bottom part. I want you to write that out in expanded form. What's a squared cubed? What does that look like?
But she said that
Can't you do this?
No, no, no. What's being cubed here? Now, what's being cubed here? What's in the parentheses? Okay, so write 3a2s for me. Oh. Because isn't that, don't you have a squared 3 times? No. Write 3a2s out. Isn't this a2, a squared times a squared times a squared?
This is wrong.
Okay, now can you break those down further? Okay, and redo these. Again, okay, with the same logic, and see if you see a pattern. Yes.
It's A to the 6th power.
Okay, so break those down. What's a cubed look like? What's a cubed look like? How do you write a cubed in expanded form? How many a's is it? 3. So write a times a times a.
Okay.
And then what do you have here? Another a cubed. So what do you write?
Another. Where did you get the another?
There's a cubed times a cubed. I'm just reading your paper.
Oh, bullshit.
That's right.
Oh.
So write out a cubed, another a cubed. Break it out.
So we can't just stop.
So how many a's do you have?
What about the 2? Where did it square?
Look at what's being squared? A to the 3. So a3 times a3. Is that not?
Twice, huh?
Yeah. Now you're breaking these down. A times a times a. So how many a's do you have?
6.
There you go. Okay.
Do we really have to break them down the whole way?
Because if you can pick it up, yes. Okay, let's look at number 4. Okay, are we all focused? Let's go. Number 4, what did you get, Lucy, in your group?
The rules?
No, I just want to know what the answer to number 4 is.
A to the 6.
A to the 6, okay? And what did you get over here, Phoebe, for number 5? And Robert's group, what did you get for number 6?
A to the 8th.
A to the 8th, okay. Did someone find a rule? Chris, what did you find out?
A to the m times n or a to the mn.
Okay. When we have an exponent within parentheses raised to an exponent, we get a to the what?
A to the m times n or a to the
A to the m times n.
n.
So he's saying, his rule is that you're going to multiply the exponents. Does that work? A squared cubed, 2 times 3 is 6, right? And then if we look at number 6, 2 times 4 is 8. Okay, so now you've got 2 rules already down. You've discovered them all by yourself. I didn't have to tell you them, right? You found that when you multiply exponents that have the same base, we're going to add them. Then when we take an exponent and raise it to a power, we're going to multiply those exponents. Okay, let's look at the third section. Okay, now we have 2 terms within the parentheses being raised to a power. Okay, expand that out, just like I did down here. 2x, we went 2x times 2x, and then we grouped our like terms. 2 times 2, we got 2 squared times x squared. Okay, do that with 7, 8, and 9, and see if you can come up with a rule.
I think you write A, B,
Then we'll let them know because I have already got
That's not already. That's more like all.
and then you
Okay.
So if we did this, A3 times B3 would be the same as AB3, right?
No, I don't know. Write that down, what you said you think it is. Okay, that's a cubed times b cubed, right? Okay, so you asked me, is it the same as what?
Okay, so it'd be AB times AB times B.
Okay.
And those aren't the same.
Yeah, they're the same. How many A's do I have? Okay, so I'm okay. But I thought you asked me, is it the same as this? AB cubed. Is it? It is? That says to me A times B times B times B. That's what you have to make sure. Okay, because this is when you asked me, that's what it sounded like you had asked. And that's not the same as that. You understand why, right? Okay, yes. Okay, try to develop your rule if you can too with your group.
you just combine them, right?
Okay, well, think about this. This is, you have AB cubed. If I were to expand this, if I was going to expand that, that would be A times B times B times B. Is that the problem I gave you? No. Okay, so find out where you went wrong with this logic. I don't see you writing this out in an expanded form. Okay? Yes.
Am I doing this right?
Yes.
Oh,
I told you, right? I understand the next step. I don't know. Okay, so far have I done it right? Because it's A times B, so that'd be AB. And then it's
3 times, yeah.
So A times AB, AB, AB.
Okay, so how many A's do you have?
3 A's and 3 B's. 3 B's.
Okay, so what does this say? That says 1 A and 3 B's.
1 A and 3 B's.
Doesn't that what that says?
Where?
Right here. Doesn't that say 1A, A to the 1 times B to the 3?
That's not what I have. I have this. Is it A cubed?
Well, I don't know. How many A's do you have?
3.
So what's 3?
Cube? A cubed? Times B cubed? And so that I was right?
Yeah.
So AB to the third is right.
Times. Is that right?
That's fine.
A cubed times B cubed?
Uh-huh.
So A cubed
And you can get rid of the multiplication. It can just be A cubed, B cubed, can it?
Sure.
Okay. Yes, Phoebe.
Okay, for number 7, wouldn't it equal, like, wouldn't you put in parentheses A times A times A, and then other parentheses you put B times B times B?
Okay, and that would equal what? Write it as powers. How many A's do you have?
A cubed
Okay. Times what?
times B cubed. So would that be the answer, or would I put AB cubed?
Okay. Write AB cubed for me.
5 times B times B times.
Okay. How many A's is that?
3.
Is it? Where's the 3 on the A?
Oh, so you have to put A cubed plus B cubed?
Are we? Did I tell you to plus?
No.
What are we doing?
Multiplying?
Okay. And how do we designate multiplying in algebra?
Parentheses?
And what other way?
And the little dot thing?
And what other way?
Times X.
And what other way? Well, if I write AB, what does that mean?
A times B?
Okay, so you can just have them next to each other, right? And that still means multiplication.
So then would I put, like, AB cubed or A cubed and B cubed?
Yep.
What? A cubed and B cubed, is that what I was doing?
Uh-huh.
Like, and B cubed, is that what I would put? That's the answer? That's how I get it?
I hope so. Keep working. See the other ones.
Put it in parentheses.
That doesn't help.
Yes, you could also do in parentheses, but we want you to get it expanded so that the powers are on each one of the variables. Okay, let's look at number 7. The quantity AB cubed. What did we find out when we had the quantity of AB cubed? Robert, how would we rewrite that? Okay, A cubed times B cubed, right? And on 8, Courtney, the quantity AB to the 5th power.
A to the 5th times B to the 5th.
Okay, and what about number 9? Ryan, you have that? AB?
It's A to the 4th and B to the 4th.
Okay, did someone find a rule? Blake?
It's A to M times B to M.
Okay, so when we have our base in here being raised to a power, each individual term is raised to that power. So we get A to the M, B to the M. Okay? And remember, when we have two variables next to each other, they're being multiplied. Okay? So there's the third rule of exponents for multiplication that you need to know. Okay? When we have the same base being raised to a power, we just add the powers. When we have a base raised to a power, we multiply the exponents. When we have two terms raised to a power within parentheses, we raise each term to that power. Okay, so now let's work on some division. Let's think about this. We're going to expand this, so this is 2 times 2 times 2 times 2. And 2 squared is 2 times 2. Okay, what is 2 over 2 equal to? 1. And what is 2 over 2 equal to? 1. So what are we left with? We're left with 1 squared, which is what? 1, right? Okay. And 2 squared, right?
So what do we do with the 1?
Okay. Okay. We take our 2 to the 4th power. We expand it out. 2 times 2 times 2 times 2. Our denominator is 2 squared, so it's 2 times 2. And we know that a number divided by itself is always 1. So this becomes 1, and this becomes 1, and 1 times 1 is 1, right? And 1 times 2 is 2. So the 1's there, we just don't have to write it. So what are we left with? 2 times 2, or 2 squared, right?
That's all you write?
Okay? Now, what is this saying? This is saying I have 4 over 2, how many times? 3 times. So how many 4's do I have?
3.
And how many 2's do I have?
3.
Okay? So do section 4 and come up with a rule for me. Section 4, problems 10 through 12. A to the 6 over a squared. That's wrong. How many a's? Look at it. These are 1's, right? How many a's do you have left? 4. And he wrote 3. Okay. And look at these. A to the 4th over a to the 1. A over a is 1, right? So how many a's would be left?
2. 3.
2.
3, because right there. 2. 1, 2, 3.
Yeah.
3. Yeah, because there's 3.
Help each other out. See if you come up with a rule on that one. Yes, Tiffany.
I don't understand how to do that one.
Okay, so how many A's do I need to write out here?
6.
So write out 6 A's.
A to the 4th, right?
Okay, and what's it being divided by?
8.
Okay, so put your division line. And then, how many A's are you going to write?
2.
Okay. Now, A over A becomes what?
1.
And A over A becomes what?
1.
Okay, and how many A's do you have left?
4.
Okay.
So wouldn't it be?
So it's 2a squared.
Why is it 2A? What's 1 times 1?
Is 11 A to the 4th?
And what's 1 times A to the 4th?
Is 11 A to the 4th? It's
So it's just a to the 4th.
Who's the smart one?
Because isn't that your multiplication? 1 times 1 is 1. 1 times A is A. And A times A is A squared. And A times...
Oh, okay.
Oh, I got it.
Yes.
Would you add these together, the 4 and 4 extra?
Okay, you have A to the 4th up top. Why do we have A to the 4th on the bottom? What's the denominator? How many A's are supposed to be down there? Okay?
Is this how you do A to the 6 and then A to the 7?
Okay.
Is this A to the 4th?
What's left here?
I still don't get how it's done.
Okay. What's this? A over A.
1.
Okay. What's this?
1.
Okay. And what's this?
4.
A to the 4th, right? What's 1 times 1?
1.
And what's 1 times A to the 4th?
A to the 4th. Oh, I got the rule now. Okay.
Does that make sense to you?
Yeah.
Scott, is this how you do A to the 6 on top and then A?
Squared on your bottom, yep.
And then A.
Yep.
Does the answer equal A to top?
And this one's A, right? Because
Okay, and see if you can find the rule now. See if you can find the rule. Okay, let's look at problem number 10. Dominic, what did you get for the answer to problem number 10? A to the 4th. Okay, Sam, on number 11, what answer did you get? A cubed. Okay, and on number 12, Chelsea, what did you get? A. Okay, do we have a rule? We have a rule. Lucia?
A to the M minus N?
A to the M minus N. So you're saying that when I have a base to an exponent and it's the same base, we take the exponents, we take the numerator and we subtract the denominator from it. Okay? Does that make sense? Yes. Okay? Very good. So now you've got the fourth rule. We only got one more rule to learn. Okay? Now on this rule, we need to take these and expand them out this way so that you can see the rule develop, okay? So go ahead and do 13 through 15 quickly. Yes. Okay.
Okay, so first we snap out, right?
A times A times A over B times B times B. So wouldn't it equal A over B? I don't know.
Well, how many A's do you have?
3.
So how do you write that?
Oh, so wouldn't it be A cubed over B cubed?
Okay. Looks good to me. Try the next one and see if you see a pattern develop. Yes.
Am I doing this one? Scott, on number 13, would it be A over B or would it just be 0? Because they all.
Okay, well, what is, you have A divided by B, right? And what power is it being raised to, okay? So it's A over,
Right?
okay?
But those both the thirds cancel out, so it'd just be A over B.
They do.
Can it be 1?
How do you know that?
Well, because they're both to the third power.
Okay, but what's to the third power? A?
And B, so it's so they're different. So it's just
So,
A over
okay, are they like terms? So can we combine unlike terms? No, so then they're in simplest form then, right?
Yeah.
Okay?
So what would the last answer be? If they're in simplest form.
It's A to the third and B to the third. But Miss Scott,
Couldn't that still be A over B then?
Miss Scott,
Yes, I'm listening, Lucia.
you said it was supposed to, like, this is all one. Didn't you? Because
Okay, so how many A's do you have?
3.
A cubed and B cubed. Right. Okay, now, let's say I had A on the bottom to go to your point, because you were saying the 3's cancel out. Okay, what if I had A cubed over A cubed? What would I have?
Then that would cancel out, and then it would be 0, right? Or no? Because they're both.
What's A? What's A over A?
Oh, it would still be
What's A over A? Okay. If I had 3 of those, what would I have?
3.
Well, what's 1 times 1 times 1?
1.
1, yeah.
1.
Okay. So if the denominator was the same variable as the numerator, yes, we could simplify it. But you can't simplify it because it's a different term, right? Okay, quickly now, let's go. Number 13. What is our answer? Robert.
A to the third over B to the third.
Good. Number 14, Austin.
8 to the 5 over the B to the 5.
Okay. And number 15, Rochelle.
A to the 6 and B over B to the 6.
Okay, and a rule. Christy. Okay, when we have the variable term in here, A divided by B, each term is raised to that power. Okay, we cannot simplify because A and B are not the same terms. Okay, now, why I have you in groups, and this is what you're going to do for today, and you're going to present your answer tomorrow. Knowing those rules of exponents, knowing different properties like distributive property, associative property, community property, I want you to prove 2 things to me. I want you to prove that A to the 0 is equal to 1, and I want you to prove that A to the negative n is equal to 1 over A to the n. This is what you're going to work on in your group right now. See if, knowing what you know about exponents, if you can come up with proof of this. Can you show me proof? Okay? That's what you're going to work on for the next 13 minutes. You'll present it to me tomorrow in class. Yes. That's why you're in groups, so start working on that. Do you need me, Robert?
I don't get it. A to the 0 is nothing, right? Yeah.
So even if you
plug in A?
No, because look at A to 0, it's A to the 0. So if you don't
If you plug in a number, it still means that there's no 1.
No, because if you plug in a number, because what if A
yes, we're right.
equals 6?
And stop. It's not multiplying anything, so.
Would this be okay? You know, 0 times everything is 0, right?
Okay.
Okay, but if A equals 1, then 1 times 0 is 0. I know, like, never mind. Never mind. Ryan made it sound better.
I made it.
Okay, well, just think about your rules of division and multiplication that you just did. Work out some sample problems and see if you can come out and prove to me why A to the 0 is 1.
Because A is 1.
No, A could be 10. And 10 to the 0 power is 1. A million to the 0 power is 1. Why is that? Think about using those rules.
That, like, just went right over my head.
Yes.
Okay, guys. He says that A 0 plus N equals 1. Isn't that 0, not 1?
That's A to the 0 equals 1. A to the 0 power equals 1.
Yeah, 0.
Wouldn't it be 0? Because anything times 0 is 0, right? But we have to prove
Unless you had
to
0
y
over
from
1 and then you reciprocated
It's not
it.
1 though.
Reciprocated it.
Okay.
I don't get how it could be 1 though, because anything times 0 is
It's going to be something that I put myself on here.
then how could it be 1?
Divide by 0.
You guys, you're trying to think of things in terms of numbers. Think about putting your rules over here that we learned about, the adding and the subtracting rules, into if you took variables, don't do numbers. How could you prove something is equal to 1? What do we know about the rule of 1? Think about that. Yes, you have a question?
Learn these. The negative ones you don't never learn those.
Oh, I know, but if you take the rules that you learned over here and think about that, you can make some examples. Using either your multiplication or your division rules up there that you developed. Let's see if you can come up with an example where that would be true. Yes?
Why do you have to multiply? Because you wouldn't have to multiply, right? So it would just be 1.
Really? What if A was a million?
Huh? A million?
Yeah, let's say A was equal to a million.
A million. 6. Huh? Equals 6.
And if A is equal, so 6 to the 0 power is 1.
Yeah.
How?
Well, that's what I want you to show me. How?
But if it says like when you multiply something by 0, it says that you're not doing anything to the, like if you had 6 times 0, it says that you're not multiplying
Okay,
by
but
anything, so it'd be 0.
we're dealing with powers now.
Yeah, I know, but I don't see how it can be different.
Oh, I know, because it's only one of these. So
That's what I was trying
it's
to
only
say.
1A because
You're on the right track. Start
only
thinking
one,
about
it's
it in
not-
terms of multiplication division now. She's on the track. Yes.
Like, what if it was like 1 times 0? That would be 0, right? If like.
Because if it
No,
were
that's not
any number
By 0 is 0.
But is that what you're saying, that it's being multiplied?
it says A to the last power, so
Is A to the 0 mean A times 0?
Oh,
No, it doesn't. What does it mean?
It would have to be 1 then, right?
No, because I can tell you that a million to the 0 power is 1.
so A times itself to
10,000 to the 0 power is 1. Start thinking about it. You're getting there. Start thinking about it.
I didn't go in first one. We're having a hard time understanding.
Okay? A to the 0 power equals 1. So any number I plug in for A, if I have it raised to the 0 power, my answer is going to be 1. That's what I'm saying. Now, think about what you can use over there between your multiplication and your division rules and prove to me that A to the 0 is 1.
Well, we thought we had it, and then we were.
Well, what did you do? Let's see.
We thought that if A equaled 1, then it would be true.
Okay, and I'm telling you that if A is equal to 100, it's true. But why? How can I get something to the 0 power? What types of things can we do? Using your rules up there. Start thinking about that. How am I going to get that 0 power? And it'll start making sense to you.
Okay, because he keeps saying that this is impossible. Because wouldn't it be A times 0 equals A?
No, because what's 2 to the 1 power? 2. Okay, what's 2 to the second power? 4. Okay, and how did you do that?
I multiplied 2 by itself.
You multiplied it twice, okay? So here, this is not saying A times 0, this is saying A to the 0 power. A to the 0 power.
That means you're not timing it by anything, so it says A, so that would be 1, right?
Well, not necessarily. What if A was equal to 1,000?
Then it'd be A to, I don't know.
No, because 1,000 to the 0 power is 1. Now you have to prove that. And think about it in terms of your multiplication and your division rules of exponents. How am I going to get A to the 0 power as a solution? What can I do mathematically to get A to the 0 power?
Mathematically get A to the 0 power. Oh, you put the plus in.
Yeah, you can use a calculator. You can use a calculator.
Wrong problem.
Put in 100 to the 0 power. See what they get. Put in 1,000 to the 0 power.
Oh, because you're just timing to get by nothing, right? So it'd be 1.
So no matter what number you're going to put into the 0 power, you're going to get 1. But using those laws right there, if you start thinking about it, work out a problem so that the solution is A to the 0, and the light will go off. It will. Start thinking, can I do a multiplication problem? Can I do a division problem? Start working with exponents. Okay? Well,
You divide it by 1 or something, so it'd have to...
well, how would you get a negative n up there looking at your rules of exponents? Look at your rules of exponents up there, and where do you think you could get a negative n?
A times M over A times N equals A and minus N.
Okay, so therefore m would have to be larger than n, right? So you can prove that to me using that law. Think about it. Okay. Now, Ryan, I figured you'd have this solved in no time.
I can't work with them.
We don't understand.
I remember learning this a long time ago. Like, it was one of those questions.
It was one of those like brain stuff where you had to like say.
Okay, so let's look at our laws of exponents. We can add, we can multiply, and we can subtract, and we can divide, right? So think if I want you to set up a problem so that the solution would be A to the 0 power. What kind of problem could you give me? With exponents. With exponents.
A to the 1.
Okay, A to the 1, and then what would I have to do to A to the 1 so that it becomes A to the 0? Divided by what? By 1 or by 0? Let's see, write that down. A to the 1 divided by, okay. Now, since we're doing division, what does the rules of exponents say? So it says that what you're going to do to get this, we want this, put this equal A to 0. A to the 0. Okay. What do we know about division rules? What do we know about division rules? What's one of the rules? You subtract the top exponent from the bottom. So how am I going to, what am I going to put down here such that this will be 0 when I'm done?
A to the 1.
A to the 1.
Okay.
So it would be A to the 0.
Now, is A to the 1 over A to the 1 equal A to the 0? Okay. Is it? By your rules. What do you do?
Yeah, because
You go 1 minus 1 is 0, okay? Now, what do you know about math when a number is over itself?
they cancel out.
And what does it equal?
1. 1.
No, come on. What does A divided by A equal?
1.
Okay, so now if we do this division, what answer do we have here?
1.
And what's that equal to?
0.
No.
one is equal.
What does that say?
A to the 0.
And what is that equal to?
1.
1.
Now, didn't you just prove it?
Yeah. So how do we write that out? Or can we just show that?
Yeah, so you guys figured this out. So now with the next problem, you use the same type of logic to solve the second set, okay?
Alright.
Now, was it as hard as you thought?
Easy.
Okay, you guys, we need to wrap it up. We need to wrap it up. I will give you time in class tomorrow to finish up. I know most of you will probably take this home and go, Mom and Dad, home. Don't worry about it. If you don't come up with a solution, we will work through and prove this for you. Okay? Yes, you have your assignments. You have homework tonight.